So let's get started and complete what we have left into the previous chapter. We will launch an instance, and through that instance we would have a Linux-based operating system and a web server running. So I would go back to console and start the process again. So I'm going to launch an instance. I am into Northern Virginia. I am on to EC2 experience. I have selected instances, and here I have a launch instance wizard which will again guide me through the process of launching an instance. I would give it a name. I think the name is quite easy here. My web server, I'll keep the same. I would call it my web server. And now I would select the application and operating system images associated or available here. It's taking a little time. Let's give it a few seconds. Now, I selected Amazon Linux. I'm happy with that. 64-bit x86 is also okay for me. I would select a T2.micro instance, which is free tier eligible. So I won't be paying money if I'm within free tier limit. We get free tier eligible 750 hours of Amazon EC2. So this should be good enough to get started. Obviously, we could compare. Now, the next thing we could select here is called key pair. Let me explain what key pair is. Now, in traditional world, when you have a operating system being installed and when you are going through the installation wizard for operating system, that time you set its if it is Windows, we call it a admin password. If it is Linux, you set something called a root password. We don't want that the same process that you manually select things here, because we want to automate as much things as can be done. So is for that, AWS uses a mechanism which is called key pair. Key pair, as the name is pair, so there are two keys. One is a public key and another part of that key is a private key. So the key is one, but it has two parts, public and private. So when a Amazon EC2 machine is getting installed for you, that machine would have the public part with the operating system itself. So this operating system, what we are having for Amazon EC2 instances, would have the public key part inside it. So this would be public key. But obviously, this public key can't be used directly to open or enter into this. Why we need these keys? Because what we may want to remotely connect to it. That remote connection can be done through a browser. So we will see some options. So we can connect through a browser. Then we can do a traditional way of doing SSH into it, and you may have used some tools like PuTTY, which allows you to get access of a Linux-based server from remotely. So that can happen, and for that, what we would be needing a private key along with us. Same key pair can be used with multiple EC2 instances. So I have one instance, I have generated key pair separately. So we can generate key pair separately and we can associate that key pair with multiple instances when we launch. Shouldn't be a problem. And once we have that private part of the key, we should be able to initiate a SSH connection for it. Why we would do SSH connection? Because maybe I want to manually check something, install something, verify some details, maybe go ahead and collect some log from there. So that's why I may use it. Not a common thing nowadays, but there are possibility if you need that access, you could go ahead and perform SSH. So hopefully this gives you idea that what is a key pair. Key pair are again region specific, so you can use a key pair to securely connect to your instance. I have already a key pair created, but let's go ahead and create a new key pair here, not a very complicated stuff. So I would give it a key pair name. I'm not very creative with the name, so I will just call it new key pair. I could select the different algorithm or encryption mechanism behind it, RSA ED2559, and I could generate the file in a format which is supported by the tools I may plan to use. So if I want to use PuTTY, PuTTY accept that file private key in a format of .ppk file, so I would use that. But if you are using tools like OpenSSH to connect, you would have it created into .pem file, and now I would say create key pair. Now As soon as I click on create key pair, if you could see here, this key pair is available to me here. So I have now this key pair coming to me. So I have this got downloaded, and this I would be using for performing further operations in my environment. So this key pair is what will be my method of accessing this EC2 machine. I have network setting. I would go with default as of now because network requires its own discussion, and we will be talking about this VPC and subnet and IP addresses into the coming section. Here is one thing which I may want to select is firewall setting of it, or that is referred as security group. So if you remember our intention that we wanted to make it as a Linux operating system based machine and run a web server and host a static page on that, that would mean I would require this machine to accept traffic on HTTPS or HTTP so that I could respond to the request when it comes in. By default, it is disabled. If I want, I could go ahead and say, okay, I want to allow HTTPS traffic or I want to allow HTTP traffic. It is up to me. And I may say I want to allow SSH traffic also or not. Now, you could go ahead and say I want to allow SSH traffic from anywhere, or you could go ahead and pick your my IP here, which is automatically current public IP address of my system. So it is giving me little more security, because now if somebody wants to do SSH, it would only be allowed if the request is coming from this IP address. Right now I do not have intention to log in. I can enable this later also, so I would uncheck it. And I do not have HTTPS secure traffic for internet right now on my machine because I would need to install a certificate for it. I just want to allow HTTP traffic only. So that is what I selected. This would create an exception into the firewall to allow traffic on HTTP, which is port number 80. Done. Once I am happy with that, I could select configuration of the storage. We will talk about storage also in a minute. And then I could go ahead and configure some additional advanced details here. Like maybe I can use something called spot instances. Maybe I want to perform some auto recovery if things go bad. I want to perform hibernation on that machine. I want to have a elastic inference accelerator, which is used for machine learning added to it. So lots of settings are available. You do not need to know everything, but one which is of interest to me is called user data. Let's see what a user data is. So just click on this info and it is much easy for you to relate what it is. Specify user data to provide command or command script to run when you launch your instance. So idea is, this is a plain vanilla copy of Linux based operating system. One option for me is to make it a web server, is let the Linux operating system boot, then I manually connect to that instance, run some command to make it a web server, host a page on that. Or what if I could put that information into a script format and let it be executed as soon as the instance gets ready for me. So that information I can pass here into user data section. It is a Linux machine, so I would be using Linux based script. If it was a Windows machine, you would have a Windows based script being added here. And I have a sample script which I am going to use for this specific Linux machine. Very simple thing. So this is called user data. You are customizing it as per your requirement at the launch time. And what I'm saying to this Linux machine, hey Linux machine, go to command prompt, use bash shell, update the current packages on it, and install a new package which is called http daemon, which will allow me to run web server. And then I want to create a page into this location var www.html, and the file name will be index.html, which is the default page for this web server. And in that I want to write a small HTML code which will say welcome to AWS. Here is my web page. And once this has been taken care, I would say, okay, now what I want to start the HTTPD service because we just installed it, not started. And I want to keep it running in the subsequent reboot also. That is this basic script is saying. Now, the script I am manually specifying here, but if you want, you may have this script stored into an S3 bucket and you could just reference it when you are launching the instance. That is also possible. So in case you want to have automation done to launch hundreds of instances and they should all be using S3 bucket based script, that is also possible. But to keep things simple, I am just creating this manually here and I would be using it from a notepad, copy paste it into the wizard here. So this is the same script which I have shown you. I'll copy this script. I'll go back to my console and here I would say, okay, let me paste it. So this script would be executed. Done. Here is a summary. How many instances? One is good enough. Software image, what type of virtual server, firewall setting, then that storage information. And once I'm happy, I would say, okay, go ahead and launch instance. That would start creating an instance for me. Here I could see that what is happening behind the scene. So it has initialized the request, creating a security group, creating security group rules in that, and launch initiation. That all has successfully done. What happened here? My instance has got a unique ID to identify itself with I dash number, which is representing my instance here. So behind the scene, what happened? Let me try to draw that so that you could relate what is happening. Based on the information we have provided to AWS, then this is the information or the request which I have provided. It has selected a system behind the scene which can run the required machine which I have asked into the request, and then it has started launching an instance for me here. So that is a base system, and on that base system now my EC2 instance is getting started, and whatever I have provided as a user data, that would be pushed inside this instance. So my user data would be executed once this instance get initialized, right? So we will come back to this whiteboard again to explain some of the concepts, but sorry, blackboard, but let me go ahead and see what is happening here. I could refresh it, so I would have a latest information here, and let me close this so we get more real estate for display. So this is my web server which we are starting. This is the name we have given. Instance ID automatically generated. It has entered into running state. Now there is a difference between operating system running and instance running. My operating system may still be going through the installation or user data script running, but instance got powered on, right? So that is displayed here that my instance has come up into a running state. My billing would start as soon as instance comes into running state. This is a T2 micro instance. We are performing some status checks on it and it is initializing as of now. There is no alarm and it has picked up one of the availability zone. This time it is US East 1E and instance is getting ready. It got a public IP address, sorry, public DNS, a public IP address, no elastic IP, no IPv6, monitoring is disabled. It has created a security group for it and it is utilizing a key pair, and this is the time when I have launched this particular instance. So those details are displayed to me here also. I could get information, and if you see this button would help you to copy information to clipboard so you could directly access it if the need be. So my instance is getting ready. What is happening behind the scene? Let's talk on this thing which is called status check. If I go further, here is a status check. And we have two type of status checks happening here. If you see, system status checks and instance status checks. What these are, let me try to draw that so you could relate to what these things are and why we may need them. Let me go back to the blackboard and we will get started. So my instance is getting started on some system behind the scene, and then my operating system is booting. That is my instance here. Now When this instance is getting initialized, AWS is performing two types of check on that. One check is to verify whether the backend system is healthy or not, and is it responding as expected or not. So that is called my system status check. That is the backend check being performed on the system itself. Now, maybe system is performing fine, but what if the operating system of the instance has crashed, or it has some issues, or it is not responding, or network could not be connected, or network is not responding? That also we perform, and that is called instance status check. So these checks are being performed behind the scene, and it will wait for it to become it will to return healthy, but it doesn't mean that my instance has not started. It has started. Probably it would start responding to my HTTP request, but maybe it waits for some time to display the status check information. So two status check, instance status check and system status check, which is being performed onto my instance here. And hopefully, if you see, this is system status check and instance, and let me refresh and see if this has passed or not. So see this, both check has passed, no issues at all on that. My instance is running healthy. Now, if you want, you could take some actions also on top of these. In case one of the instance status check fail or system status check fails, you could say what should be the next course of action. Do you want to restart that instance or recreate it or just shut down? So that configuration is possible. We can do that if the need be. Right now I'm keeping it simple. So we just have created an instance. If I go to that instance detail, I could see it got a public IP address. Now, why it got a public IP address? Because I launched it with the default VPC, which is virtual private cloud, in which my instance got a public IP. But depending on your use case, you may launch it into a VPC or into a subnet where it may not get a public IP address. We will talk about that. So I would go ahead and click on this. I would copy that information and open it into a web browser. And if everything was fine, I should start seeing a small web page which has come up here. Welcome to AWS. Here is my web page. Now, I could go back here on my instance. Sorry, let me come back here and I can open address here. Now, if you click on that, that may not work. I'll give you rationale behind it, what is happening here. When you click on that open address, this request is going on HTTPS, not HTTP. So that's why it is not responding, because I have not enabled HTTPS traffic on my security group, and there is nothing responding behind the scene, and that's why we are getting failed. But if I'm accessing it on standard HTTP, which is not secure, that's completely fine. I will get my response. So my instance is now ready and working healthy, as we could see here. Okay. Other details, we will talk about them as we move forward, but the most important one here is my instance is running or not, or whether its status checks are passed or not, right? And if you want to access your instance by a public DNS name, that also has been automatically given to it. So this is referred as EC2, and this is the public IP address. If you relate this information here, this is a public IP address. .compute-1 amazonaws.com, and if I access this thing here, it should also be displaying it. Again, it will be coming to same web page. So either I refer it using IP address or I refer it using DNS address, I would be able to access the content of the instance which we have launched. So I hope this thing is clear. You got understanding of how to launch an instance, how to get information about the status checks, some details which are displayed here. One more important information I want to talk about here is tags. Now tags can help you in various ways. I will just focus right now on tags for your information or identification purpose. So here I could say, hey, I want to manage tags and I'm adding extra information here. I would say this belongs to the class, which is, let's say, demo, right? Then I would say this belongs to owner, and I would say this belongs to Ash. I could go ahead and add other tag. Maybe it is commercial, and I would say cost center, I say it is free tier, something like that. So additional information which I am adding with my instance to make it easily identifiable, because this is one instance in my account. In enterprises you would have hundreds, thousands of instances running, so at least identification should be there. So that's what a tag is. You can have up to 50 tags assigned to an instance, should not be a problem, and tag can help you in automation too. We will talk about them when the time comes. So hopefully this thing is clear. I'll stop now and then we will perform some additional operation on this instance, and we will understand the various storage options associated with the instance. So I hope you learned something new. I'll talk to you into next section. Thank you.